Welcome back. So in the last video I talked about what happens when some angle is either added or subtracted from y equals sin x. So the angle is subtracted, not a value is added. Y is equal sin x and y is equal sin x plus 30 and y is equal sin x minus 30. I discussed that. So that was a simple example. So what happens if y is equal to sin 2x? So if y is equal to sin 2x, you can draw simply that graph again. So you can take this graph, draw the table again. So it's easy for any graph you can take like that. So this is x, this is 2x, so this is y equals sin 2x. And x equals 30 and x equals 45 and when x equals 60. So when x is equal to 30, 2x is equal to 60, and when x is equal to 45, 2x is equal to 90, and when x is equal to 60, 2x is equal to 120. So when x is equal to 30 and 2x equal to 60, y equals sin 60, so that is equal to root 3 by 2. When x is equal to 45 and 2x equal to 90, y equals sin 90, so that is equal to 1. So when x is equal to 60 and 2x equals to 120, y equals sin 120, so that's also equal to y equals sin 60. So that's again root 3 by 2. So the graph of y equals sin x I have drawn in the time, so I will draw it again to show you how this graph actually varies. So you may not need by now, I have drawn it enough in this series of lectures. So 0, you will be bored of drawing it again, but it will be easy for you to compare. So I will be drawing all these graphs again and again. So at 0 it is equal to 0, at 5 by 2 is equal to plus 1, and 0 here minus 1. So the amplitude will be the same because for graphs y equals sin x and y equals sin 2x, the coefficient of sin x and sin 2x are the same, that's equal to plus 1. So the amplitude will be the same, amplitude will not change. So the what actually changes is like this. So this sin x is y equals sin x is like this. Goes to here, goes to here, and goes to here. So this is y equals sin x. When y is equal to sin 2x, what happens is at 30 degrees, y equals, if you want to draw another table here, okay, now actually I don't need to table again. At 30 I can write straight away. Or it's easy for you to take this portion out here, like this. That will be multiplied actually. X, right? So this is 0, this is 30, that is 5 by 6. This is 45, this is 5 by 4, and this is 60. I have taken only the values of 30, 45 and 60. Alright, so 60 is equal to 5 by 3. So at sin 30, in the sin x graph, sin 30 is equal to, so the maximum value should be 1. So sin 30 is equal to half, so let's manipulate this. So here, sin 45 is equal to 1 upon root 2, so that is root 2 by 2. Root 2 is 1.21 something like that. So root 2 will be 1.414. So root 2 by 2 is 0.707. So 0.707 is greater than this, so it will be somewhere here. I take 0.7. So 45 will be here. Alright? and 60, sin 60 is equal to root 3 by 2. Root 3 is 1.732 and root 3 by 2 is 0.86. So it will be somewhere here greater than this. So the actual angle is greater increasing. So this is the y equals sin x graph between 0 and 60 degrees. So 0 and 5 by 3 radians. So this is sin x graph, y equals sin x graph. So what is y equals sin 2x? So x at 30 degrees, when x is equal to 30, y is equal to root 3 by 2. So that's equal here. Right? When x is equal to 45, y is equal to 1. So this is somewhere here. So when x is equal to 60, y equals sin 120, so that is root 3 by 2 here. So the graph will be, when x is equal to 0, y equals to sin 0, that's 0. So the graph will be like this. So this is y equals sin 2x. Right? When x is equal to 60, sin 60 is equal to root 3 by 2, that's 0.86. What actually happened is that just differentiate these two graphs. This is the first graph here, is y equals sin x. The graph that is below here. And the graph that is above here, y is equal to sin 2x. So what actually happens is when the angle is increased, it achieves the same displacement, half of the value as before. So when I don't talk to you about the angle that was when x is and the graph transformation or the phase transformation when x is either the phase is increased or decreased when x is equal to plus 30 or x is equal to, so the phi is equal to plus 30 or phi is equal to minus 30, and when phi is equal to plus 30 the graph will be y equals sin x plus 30, and it will shift when the phase is increased by 30 degrees, it will shift 30 degrees leftward. And when phi is equal to minus 30, y equals sin x minus 30. So when the phase is decreased by minus 30, the graph will shift 30 degrees to the right. So what actually happens when y is equal to sin 2x, without changing the phase, taking the initial and the final phase both as 0, what actually happens when the coefficient or the value of b is increased by 2 is this. You can take the period equals 2 phi by b, so that's equal to 2 phi by b is equal to 2 here because sin 2x, the coefficient of x is 2, so the period is 5. So the period is 5 means for the sin x graph you know that the period is 2 phi, so that's the wavelength as described in the first video. So the period is 2 phi for sin x, y equals sin x, and for y equals sin 2x the period is 5. So actually what happens is that the graph is shrinked here, compressed like as if you are compressing a spring, compressed here. So the y equals sin 2x graph will be something, if at 5 by 2 it will be 0. So what happens is this point will come here and this point will go here. So this point will come here and this point will go here and this point will be somewhere here between this. So what actually happens is this graph is shrink. So the final graph of y equals sin 2x will be like this. This x, this is y, this is 0, this is 5 by 2, this is 5. So the graph will be like this. So this is y equals sin 2x, the graph. At 5 by 4 it will achieve the angle that is achieved by y equals sin x at 5 by 2, so this will be plus 1 here. At 5 by 2 it will achieve the displacement from the main axis that is achieved twice that in the sin x graph. So the value of sin 5 by 2 in sin 2x is the same as the value of sin 5 in y equals sin x, so that will be 0 here. And at 3 5 by 4 here, the value of twice this value in sin x, that is 3 5 by 2, will be the same as 3 5 by 4 in y equals sin 2x. So that will be minus 1 here. So the amplitude will not change because the amplitude, the coefficient of sin x is the same. And at 5 it will achieve the same value as it was at 2 phi in sin x. So it will be 0 again. So the graph will be like this. Shrink. So this is the new graph and this is the old graph. Actually it's shrinking. So if y is equal to sin 1/3 x, what happens is that the graph is shrinked by period equals 2 phi by 1/3, and the period is 2 phi times 3. So period is increased by 3. The period is increased by 3 is the graph. Here the graph is pulled here. So the initial position will be 0 for the graph, amplitude will be 1, and the period will be 6 phi, not 2 phi. So in the graph of y equals sine 2x, it actually happens is the graph is shrinking, and if y is equal to fraction that is between 0 and 1, the graph will be released, like releasing the spring, compressing the spring and releasing the spring. So y equals sine 1/3 x, or y equals sine 1/8 x, or y equals sine 1/4 x will be 4 times, 3 times and 8 times respectively. You can take the period and determine the graph. You don't have to take the values actually, you can take the period and determine how the graph changes. So if y is equal to sine minus something, you can take that minus. You know that from the even odd functions I described in the first set of videos. If I am not, I am saying again and again, if you are not watched that video and the series of videos of that series, any video of that series, you can watch it. And in even odd functions or even odd identities, according to the formats I have described on the 11 identities on trigonometry, I described that even odd identities, if sine y equals sine minus theta, y is also equal to minus sine theta. So if y is equal to sine minus theta, y equals minus sine theta. So if y is equal to sine minus 2 theta, that will be equal to minus sine 2 theta. So what happens is that now you know if y is equal to sine theta or sine x, to draw the graph of y equals sine x and draw the graph of minus sine 2x. Sine 2x. So what happens is that if y is equal to sine minus 2x, the graph will be the same as graph of y is equal to minus sine 2x. So you know how to draw the graph of sine 2x. So I have taught you how to draw the graph of y equals minus sine x by drawing the graph of y equals sine x. So what you can do is you can draw the graph of y equals sine x, then you can draw the graph of y equals sine 2x, then you can flip it to 180 degrees and draw the graph of y is equal to minus sine 2x. So since minus sine 2x is equal to sine minus 2x, so the graph of y is equal to sine minus 2x will be the final graph. So if y is equal to sine some fraction, you can take the fraction there and put the minus sign out. You can draw the fraction. If y is equal to sine 1/3 x, you can take, the period is 6 phi, so the 3 times the period of this one. So you know that, and then you can draw that graph y equals sine 1/3 x, and then you can flip it over 180 degrees and show that y equals minus sine 1/3 x is the same as y is equal to sine minus 1/3 x. So you can draw the final graph like that. So that's just the increasing the angle, the coefficient or the b value of that. So I have taught you how to increase the value of a, how to increase the value of phi, how to increase the value of b, and then I have told you how to decrease the value of a, decrease the value of b, decrease the value of phi, and how to change when it is an integer or fraction. So that's the end of the transformations. Now I will, in the next video actually, I will talk to you about a combined problem. That is, first of all I will combine the amplitude transformation with phase transformations, and then I will combine all three: phase transformations, amplitude transformations, and doubling and increasing the angle, increasing the b value. I will first increase the a value and phi value together, and then I will increase a, b and phi together. So those two examples will be solved in the next video, and I welcome you to watch that video, and thanks for watching this video, and see you soon.